Hello and welcome to my quick run through of the Unity Create with Code Unit 1 lab. So this is just going to be a quick demonstration of what it looks like to actually do the lab. This video isn't going to be a full lesson. If you're looking for the actual complete tutorial, I highly recommend going to the Create with Code website. I'll put a link below. But this I imagine will be most useful if you've already done the lab, or if you want to just compare the way someone else might work through a similar problem with a bit of explanation along the way, or if you just kind of want to watch someone working in Unity a little bit. I'm making this video in conjunction with an actual class I'm teaching based around the Create with Code curriculum. And it's worth mentioning that I'm not actively looking at the lab at the moment. I've read through it in the past. I know what the endpoint is, and I know most of the steps, but what you see here may not be exactly the same, and that's kind of what I'm hoping for, because this is just going to be me walking through my own thought process as I try to work from start to finish, along with a few intermediate steps, just as I feel it's helpful to mention a few things. With that said, I'm just going to go ahead and dive into the lab. So you can see here I have the prototype pulled up for the Unit 1 tutorial. To show you where I got this, if I just hop over to the Create with Code website here, on lesson 1.1, there's this tab called Tutorial Materials that has a link to the asset store prototype 1, which opens this. And if I open it in Unity, that'll pull it open here. And I've clicked Import, which has put the course library over here into my project. If I expand my scenes, you can see there's a prototype 1 scene, and that is what we are currently looking at up here. Worth mentioning, your Unity editor may look slightly different. I've rearranged this to be the way that I like working with it, in that I have my editor up here and then my game view down here. So that's actually what the camera's seeing at any given point in time. Anyway, so if I'm going to start making this project, I know my goal is to have a car that I can control forward and backward and steer to dodge some obstacles. And if I crash the obstacles, I want them to act like an actual thing in the world that I'm hitting with a car. So probably a logical first thing is we're going to want a car. If I expand my course library, I've got some vehicle models they've given me here, and I'm just going to grab this truck here. Why not? I'm going to do a little bit of manual editing. It's given me its coordinates where I happen to drop it down, but I'm going to just clean this up and make it 0, 0, 0, put it right at the origin. So there we go. We've got our car positioned in the screen. If I run the game, nothing really happens because we haven't done anything to it yet. But we have a car, and it's sitting there, and it looks nice. So step one that we probably want to do is we want our car to move forward. Down here in my assets, I've made a folder called scripts, which is generally a good practice in order to keep track of stuff. And on scripts, I'm going to right click, create C# script, and I'm going to name it vehicle controller. It's descriptive. I know that whatever code I put in here is intended to be the controls for the vehicle itself. So now that I have that, if I open Visual Studio and reload it because I redid my project, here it is. Here's the script that we just created. And it's got a few auto-generated things. I'm not going to go extremely in-depth on what Unity classes look like, what mono behavior is, why it looks like this in this lesson. But it's worth mentioning briefly as these comments describe. Start, any code that you put in here is going to run once when you first hit the play button. And update, any code you put in here is going to run on every frame. So we want our car to move forward. In order to do that, my car has a transform component. So actually coming back over here, if I have my car selected and I'm looking over in my inspector over here, it's got this component called transform. This is what I'm working with, and it's got an X, Y, and a Z. So transform has a method called translate. And this helpful little thing that pops up here tells me the different options I have. So it takes in a vector 3. I'm going to start out by doing that manually and just calling a new vector 3, and I want it to move forward I want it to move forward. And if I come here and look at my car, I'm going to see that it's got this coordinate system and it's got this blue arrow. This is the way I want my car to move. Undo that. There we go. And then up in the upper right corner, as you look at this, you can tell that the blue arrow is our Z direction. So going back to my code, new vector 3, I want it to move 0 in the X, 0 in the Y, let's say 1 in the Z to start. So now every frame, the position of my car should change by 0 in X, 0 in Y, 1 in Z. So let's go ahead and save that. Come back over here, and in order for that to apply, I need to drag my script onto my vehicle and drop it there. So you can see now over in the inspector, my vehicle controller has appeared here. The inspector, when you have an object highlighted, shows all of the components that currently apply to it. My vehicle controller is now a component that it has, which means it's going to run that code. So every frame that will execute on this vehicle. So now if I run my game, there goes my car. It's exciting, it's moving forward, but not super helpful in terms of an actual game. The other thing is that seemed like a reasonable speed, but there's an important detail in the fact that update is called once per frame. And that's, if you know much about games, you know that frame rates can change. Sometimes your game might be running at 60 frames per second, but then maybe you start doing something computationally intensive and it drops to 30 frames per second. Well, if this exact code is running at 30 frames instead of 60 frames, your car is going to change speeds. So what we need to do is multiply this by time.delta time. And what time.delta time does is this will be the value. You can rely on this to be the amount of time that has elapsed between the previous frame and this frame. So even if the frames change, if the frame rate varies, time.delta time is going to make sure that this distance is always going to be constant in human time as opposed to frame time. Another little shortcut I'm going to do here that's just a useful shorthand to know and makes your code easy to read. Vector3 has this thing on it called vector3.forward. It's a pretty common thing to want to be able to move forward. So vector3.forward is exactly the same as a vector that's just 0, 0, 1. It has a bunch of other shortcuts. So there's also like a vector3.right or vector3.up. It's a more readable way to know which direction you're moving things within the game than always having to know those specific numbers to type in. So if I now save this and go back to my game and run my game, it's moving really slowly. And the reason it's doing that is because time.delta time is a very, very small number. It's like a 60th of 1 if it's going at 60 frames per second. So let's just multiply this by a number to make it go a little faster. I'll pick something arbitrary like 20. So now hopefully if I come back over here and run it, that looks a little better. In fact, that actually looks pretty good. But you might not always know exactly what the number is, and it's going to be kind of annoying to come over here and change this number over and over and over again. Plus, if you ever want to reference it in a different place, say I have 3 or 4 different places that might move the vehicle and I have to type the number 20 every time, and then I decide it needs to be 15, I might change 3 of them and forget about the 4th. All that to say, it's usually much better practice to create an instance variable up here. So let's make something called speed and set it equal to 20. And down here, multiply this by speed. As I mentioned before, I'm not going to go too deep into coding. If you aren't familiar with instance variables and attributes and that sort of thing, and object-oriented programming, I'll follow this up eventually with a lesson on coding in C# as well, but that may be a useful thing to review. For now, the important point is that the value up here is something that's going to exist on the object, and it's going to be accessible throughout its lifetime. So it's not going to run every frame. It's just there, and I can reference this whenever and edit it whenever, and the object will always know about it. So this should, in theory, have the exact same effect if I run it. There we go. But a really useful thing to notice is that down here on my vehicle controller attribute, there is now a field called speed that has that value of 20 I put in it. So if I wasn't happy with that and thought, nah, I want it to go a little slower, I can make this 10. And now without editing my code, my vehicle's slower. In fact, I can edit that live while the game is running. So let's make it go really slow. That's too slow. Let's make it go a little faster. I can click and drag this to make the number go up. Faster, slower, negative. So it's useful to test, like, I think 20 seemed like a pretty reasonable speed, and I like that number. So I'm going to leave it on 20. Okay, That's great. The car's moving forward. But generally, when you're playing a game and driving a vehicle, it doesn't just keep moving forward forever. You want to be able to push forward and backward to control when it's driving forward and backward. So let's make a few changes. Whoops, not what I meant to do. Back over to here. I want to know if my user is pushing forward or backward. So I'm going to get a float variable called vertical input. And there's another class called input, and it has a method on it called GetAxis. And I want the vertical axis. This is something that when I started learning Unity for the first time, I was kind of confused about why this worked. Like, why does vertical axis know? Because this knows that vertical is the up and down and W and S arrow keys. I don't think the Create with Code tutorial mentions this much, but I'm going to very quickly show you why that does this. If I, in my project, go to Edit Project Settings, there's this Input tab here. And the Input tab has a drop-down called Axes. And if I drop that down, it's got a bunch of different axes, and one of them here is vertical. If I drop down the vertical axis, negative button down, positive button up, alternative negative button S, alternative positive button W. So that's why WS down and up work if you say get axis vertical. And there are a bunch of other ones. So horizontal is going to have left and right. Fire 1 is by default defined to be left control or mouse 0. You can edit these. I wouldn't recommend messing around with it too much right now. And in fact, when I'm working in Unity, I usually don't use this very much. But I'll save the way that I do it for the lab 2 and 3 descriptions because it comes up a little more there. For now, all you really need to know is that this is why that magic name vertical works and why over here, this is going to do what I want it to. And important, you saw that it had a positive and a negative input button. That's because GetAxis is always going to give you a value between -1 and 1 based on how much you are pushing the positive and or negative buttons. In a case like this where I'm using a keyboard, if I'm pushing forward or W, it's always going to be 1. If I'm pushing down or S, it's always going to be -1. And if I'm pushing both at the same time, it's going to be 0. It gets a little bit more interesting when you have joysticks and you can have in-betweens and all that. But for now, know that this value is going to be either -1, 0, or 1. What I can do now is if I multiply this by vertical input, if I'm not pushing any buttons, GetAxis vertical makes this 0, and so I multiply my move by 0 and it holds still. If I'm pushing forward, this is 1, and I multiply the whole thing by 1 and it moves exactly the way it did before. And similarly, if I'm pushing down or S, it's -1 and it will reverse the whole thing. So, save my script, go back over to my game, run my game. Car's not moving. But I push forward, and there it goes. And my speed is on 1, so the car is moving horribly slow. That's not what I want. I want you to be 20. Let's try that again. There we go. That's more reasonable. And in fact, 20 might be a little too fast. Let's make that 15. All right. So now we have a car that moves forward and backward. We want this to be a little bit more like a game, so let's give it some stuff it needs to dodge. In my course library, they have also given us some obstacles. So let's pick an obstacle like a crate. Throw a crate in the road where the car is going to hit it. Do a little bit of adjusting, and I want it to be at like 0, 0, and let's say 20. Sure, that seems reasonable. Now let's run the game. And drive forward. Uh-oh. It goes straight through the box. So that's not great. Unless our plan was to have a ghost box. So why is that? If we look at our car here, and we go back to those components we were talking about earlier, we're going to give it another component. And there's a component defined in Unity called rigid body. And what rigid body does is it makes the object it's applied to act like an actual object with physics. So now we have gravity. We have a mass. If I look at my box over here, we probably want it to have that too. So now our box is also going to act like a physics object and have gravity and everything. Which means if I drive, there we go. That looks much better. we hit the box and it flew out of the way. Another thing worth pointing out is that these objects already have this mesh collider on them here. That's what lets them know that they're crashing into anything. If I were to, let's say, go to this box and delete its collider, remove component, and then play my game, oops, I deleted that for the road, not the box. That would be really bad. There we go. Here we go. So you've got a mesh collider. Let's just toggle you off and hit play. It falls straight through the world because it's no longer colliding with the ground. So we need that mesh collider so that it knows it's hitting the road. And when the car hits it, it knows it's hitting the car. Cool. One object is kind of boring. Let's make a couple more. Useful shortcut here, if I select my crate and I hit Control D for duplicate, now I've got two of them. And then I control click here and I've selected them both. Control D. Now I've got four. And just like these, Control D. And now I've got 8. So now that looks much more like an obstacle course I can drive through. And because I duplicated it, they should all already have that rigid body applied. I'm going to group these just to make them a little easier to hide because these crates all have weird names. A thing you can do anytime is I'm going to come over here in the hierarchy and create an empty game object. I'm not really going to use that for anything, except I can create children under it. So if I put all my crates under here, and then I just name this obstacles, I just grouped a little nicer now. Similar things happening here with the environment where this dropdown has all the different like segments of road, so you don't have to see them all the time. So there are my obstacles. I've got 8 crates. If I run the game now, can't really see my car. There it comes, crashing through some boxes. And then it turned sideways and it fell off the world. So that's not great. There goes our car. Goodbye. We need to be able to turn so we can avoid our boxes. Actually, before that, we've been driving using flying around in the editor. We probably want our game camera down here to actually look at our car. That seems way more helpful. So I'm going to go ahead and just position the camera somewhere a little bit more useful to start. I've got my move tool selected, so if I move my camera like there, and then up a little, then back a little, and then I'm probably going to want to rotate it like 90 degrees around the y-axis. It seems a little better. I know that my car's position, my car's position is at 0x 0z, so maybe let's make this like negative 10z. We want to look down a little, so in order to look down, we want to rotate around the x-axis, which is this red arrow here. So maybe it's like 45 degrees down. Too much. 30. That's better. Maybe a little lower down. 8. Yeah, a little flatter. 20. So this is kind of, you end up doing a lot of playing around like this to make sure your camera's where you like it. So that's a little better. If I run the game now, I can at least see what it's doing. So we'll leave it there for now. I'll come back to the camera control near the end. Oh, there goes our car. But other things that we want to do, we want to be able to steer the car. So similar to how we have a vertical input here, we're going to need a horizontal input. I'm just going to copy this and make another thing called horizontal input and GetAxis horizontal. I'm going to actually move this down below here. So drive forward is one thing we want to do. Turn is another thing we want to do. So now we're getting a value between 1 and -1 about how much we're turning. Similar to how we have this transform.translate here, transform also has a rotate method. And rotate can also take a vector 3. In this case, the important part is that the vector 3 that rotate takes is what axis you are going to rotate around. So if I come over here, I want the car to rotate left and right which means I want the car to rotate around probably this green arrow. I can check if that's true by coming up here and saying, okay, y-axis I think is the one I want. Yeah, that seems like reasonable for turning. That's my dog making noise in the background. So yeah, it seems like the y-axis is the one I want to rotate around, and that's an arrow pointing up. So if I come back over here, I want to rotate around vector 3 dot up. So now that we've got our rotation around the up axis, we probably want to multiply that by the value we're getting for a horizontal input. And then similar to speed, we aren't really going to know. I guess let's take a look quick and see what that looks like if we just go ahead and do this. If I come over to my game and run it, and I drive and try to turn, it's turning. It's not turning fast, but it's turning. So what we can do is similar to how we have a speed for our driving forward and backward. Let's give it a rotation speed. Say 10, just arbitrarily. Back to our game, run our game. Probably going to turn a little bit faster. A little bit. In fact, no, it's not, because I forgot to multiply that down here. That's better. There we whoa. So yeah, trial and error, helpful. That turns a little too fast. Let's change our, so now down here you can see in our vehicle controller, we have rotation speed now. Let's make that like, let's make it even lower. Let's make it like 2. Ah, but wait, we forgot another thing in that similarly, this also should have a time, delta time, because it's also going to be dependent on frame rate. I've kind of put these in a different order than I did last time, so just to make this easier to read, let's go vector 3 up times time delta time times speed times horizontal input. Now it just reads the same as our vertical one. Back over here, run. Whoa. That's not what I meant to do. I'm moving a little too quickly. There we go. Now it's really slow to turn because of that. Okay. We need rotation speed up to like 20. How's that going to look? Probably still going to be too slow. Yep, way too slow. Because we're going in degrees. So let's call this 90. Nope, still real slow. 200. The fun of trial and error. Things I should... This doesn't seem to be applying. Ha. Yep. Gotta love live demos. These are the kind of mistakes that happen no matter how long you have been programming. Just 8 hours a day, and I still miss stuff all the time. That's better. Now our rotation speed is going to affect it, which means this is probably going to... that seems pretty reasonable, actually. Maybe a little too much. Let's call it 120. Yeah, sure. That seems like something we could drive. We can dodge boxes. We can crash through boxes. It's something. Oh, flying vehicle. All right. So now we can drive our car forward and backward, and we can steer it. We're going to want our camera to follow the car. Probably going to be way more useful. Our camera's also slightly offset of the car, it seems like. Actually, no, it's not. It seems pretty good. Yeah. So we want our camera to follow the car. So we're going to make a new script. And we're going to call it our camera controller. As usual, good descriptive name. We know exactly what it does. Now, here's the tricky part about the camera controller. I could do the same thing as vehicle. I could go ahead and put in fact, just to demonstrate, you might have the idea like, oh, okay, I want it to do the exact same thing. I'm just going to take the vehicle controller and put it on my camera here. Well, it's going to rotate, so that's going to make things very weird. Yeah, let's not worry about that. You could put controls based on pushing forward and backward. I'm going to take this component off of here. The same way you're doing with the car. But more useful is to have the camera actually know where the car is at all times. So I'm going to go into our camera controller here. And this is one of the most useful things in Unity. I want the camera to have some idea of where my car is. So I'm going to give it a game object, and I need that to be public. Game object vehicle. So now it has an attribute that's a generic game object, as everything is in a scene inside of Unity, called vehicle. Because that's a public instance variable, if I take my camera controller and apply it to my camera, my main camera here, and I open it, in my components, here's our camera controller, and it now has a field called vehicle that says none. But if I go up to my car up here and I click and drag it, well, don't click on it first because I need this window open. Click and drag. You can see that this highlights, and when I let go, vehicle UTE red Z, whatever this is called, is now here. In fact, I'm going to just rename this so it's clearer. This is now just called vehicle. So there we go. Our vehicle is now the correct vehicle. In fact, that's still a little confusing because of that. Let's call it our player vehicle. Sure, why not? So now our player vehicle is there. What that means is that in our code for the camera, it now knows about our vehicle. And that includes things like our vehicle's transform, which gives us its position. So what I can do here is I now want to change the position of my camera. So if I say transform, which is my camera's transform, dot position, the position of my camera, and I'm going to set that equal to vehicle transform position. So now my camera's position every frame will be updated to be the same position as my vehicle. You probably already see where that's going to be a slight issue, but if I come over here and run it, it works. We're moving with our vehicle, but we are now inside of it, which isn't great. Luckily, there's a really easy way to change this in that we know before. In fact, let's go back over to our game here. We can see that our camera's position, this seems like a pretty good view down here. Our camera right now is 10 behind and 8 above our car, because our car's at 0, 0, 0. And our camera's at 0, 8, negative 10. So what if I just add 0, 8, negative 10 to the position? Now I run it. And how about that? Our camera's following our car, and we can drive around. Whoop, and we can crash. And off the world we go. So there are still some quirks. But in general, this is pretty good for a first cut at the lab. I can drive. I can dodge boxes. If I hit them, they crash out of the way. Interesting challenges to work on if you wanted to extend this lab. This isn't really how cars drive. You can't really spin in a circle. So you might want to make this dependent on if you're moving forward or backward. That's a good challenge to work on. Another thing is right now the camera's always facing down the road. I might want to see where my car is driving as I'm going forward. But this is a useful example as a first cut at doing this lab. Other things. My car's upside down. Probably shouldn't be able to drive. But hey. This completes the assignment for the first lab as we fall out of the world here. Yeah, so that was Unity Create with Code Unit 1. If you have any questions, feel free to leave a comment below, reach out. If you're in my class, I will see you on Wednesday. And thank you so much for taking the time to watch this.